Hello YouTube, and welcome back to part 3 of my Intel Haswell overclocking guide. This part will focus on finding memory stability. Now basically, a few things to keep in mind when we're talking about memory stability. First thing to always consider is that you take the best CPU frequency that you can get, and always, if there is a trade-off, you may have to sacrifice your memory frequency. So if you made it this far in the guide, you've basically found the best CPU frequency and the best ring bus for your Haswell CPU. And now we can basically move on into ensuring that your XMP profiles are good to go, or your default parameters for your memory can run with your overclocked CPU. First thing I'd like to touch on is that XMP profiles can be very misleading, so you have to be aware that you may not get the specified XMP values indicated from the manufacturer, and we're going to go through a whole lot of that. This guide will primarily focus on finding default memory stability. I am not talking about overclocking memory whatsoever. There really is no benefit from overclocking your memory in the real world when it comes down to playing games or rendering videos. You know, very few applications can actually engage and use all of the memory bandwidth that's available. So in terms of finding higher frequencies, you're kind of on your own. There's lots of information on YouTube and on the internet on how to overclock your memory if you're interested in that. In my opinion, tighter timings are more beneficial than higher frequencies, simply because higher frequencies tend to require higher voltages, and just memory can be a very finicky item, even trying to run default parameters. So it is always okay an idea to keep the memory voltage as low as possible. However, I personally like to overclock my memory. I like to give it a lot of volts. So I mean, if you're into overclocking in gigahertz, yeah, give it volts, give it frequency, do what you got to do. You know, if synthetic benchmark values make you happy, by all means do that. I mean, I do it personally as well. So but overall, if I were to suggest something, I would say go with lower voltages, tighter timings, and you know, don't overclock the memory frequency. So XMP profiles change basically three things when you load everything to auto and simply engage the XMP profile. The three things that it changes is the memory speed, the memory timings, and the memory voltages. Now keep something in mind. Most memory manufacturers will only officially support JEDEC standards of their memory kits, not the XMP profiles. And I'm going to give you an example in a second on what I'm talking about. Also, XMP profiles are technically considered overclocking, so once again, there is no official support from most manufacturers when it comes to XMP profiles. Now I'm going to give you an example of this. The kit that I'm running is this kit right here. It's a Kingston HyperX B series kit, DDR3 2400 CL11. I purchased this kit from Direct Canada, and since I've purchased the kit, they've actually updated the website. Now you can see right here that the XMP timing parameters, they list the JEDEC standard as well as the XMP profile. Now you can clearly see that the JEDEC standard is DDR3 1333 CL9 1.5 volts. I contacted Kingston, and this is the only setting that they will actually support. The XM profile suggests DDR3 2400 megahertz CL11 at 1.65 volts. They have updated this website, and if I look under the specifications right here, the memory voltage is 1.7 volts. When I purchased the kit, this was not available, so I was under the assumption that I was able to run this frequency at this voltage. That, however, was wrong. Through my testing, I did verify that I could run 1.7 volts and get this memory stable at the rated frequencies and timings. So be very aware that the XMP profile can be very misleading. You may have to contact your memory manufacturer to see what they officially support. If you're currently in the market to buy new memory, it may not be a bad idea to contact the manufacturer's technical support team and see what they officially support that particular product for. So that's a little bit of insight on XMP advertising and real-world specifications and what you may have to change in order to get your XMP profile loaded up. So for example, if I left everything to auto, this kit would have booted at 1.65 volts, which I did, and it blue screened right away. After increasing the voltage to 1.7 volts, I was able to get my kit stable for 8 or more hours while stress testing. Also, if you're not sure, sometimes CPU-Z will give you the specified speeds of your memory. So this is CPU-Z under the SPD or speed tab, and if you look here, you can see the JDEC standards that are supported by the kit. Basically 1333 at 1.5 volts, CL9 99925. The XMP profiles suggest actually a command rate of 1T. However, the manufacturer for this XMP profile suggests the command rate of 2T, which is true because 1T is not stable. So this information on CPU-Z it can be inaccurate as well. But this is just an example of the same kit, what it's actually showing me, and Kingston will support this 1333 at 1.5 volts. They will not officially support either of these XMP profiles. There's 2 that are loaded on these kits, and there is no official support for that. So please bear that in mind if you are purchasing memory or if you're having a hard time overclocking your memory. Always contact the manufacturer for technical support if you have any questions or concerns in regards to what the memory will actually support. So, for us to carry on here, so once again, XMP profiles are considered overclocking. So the first thing that we're going to have you guys do is set your memory frequency to auto, set your DRAM timing configuration to auto, set your memory DRAM voltage to auto, load desired XMP profile. You may have more than one. My kit had more than one, so load whichever one you prefer to run. Boot and stress test with the Intel Extreme Tuning Utility memory stress test. Your CPU temperatures may be slightly higher than the regular CPU stress test, and this is okay. You're utilizing a little bit more resources, so the CPU is working a little bit harder, and that's fine. So if through your testing you are averaging certain temps, don't be alarmed if your CPU temperatures increase under the same ambient conditions. I actually prefer to use the Intel Extreme Tuning Utility CPU stress test and not the IETU memory stress test. And the reason for this is because I know that I validated my CPU for 8 hours under that stress test. I've also validated the CPU ring bus for 8 hours or more under that stress test. So if it crashes within that 8 hours, I basically know that the cause is the memory and not either the CPU or the ring bus. However, the Intel Extreme Tuning Utility is not the best stress testing program. There's no way for it to actually utilize more system memory. In my case, I have a total of 16 gigabytes of usable system memory. It will only use about 4 gigabytes. So some programs such as Prime 95 allow you to allocate more memory to the stress test, same with OCCT. So if you do use one of those stress testing programs to basically put more stress on your memory, make sure to set your CPU vCore mode to manual. This is very important. Using any other stress test in the Intel Extreme Tuning Utility will most likely increase your CPU voltage. Now, if you've been following this guide step by step, we haven't touched the vCore mode yet. We're going to set that for adaptive in part 4 when we set all of our power efficiency parameters. So that's just one thing I wanted to mention. If you use a different memory stress testing program other than the Intel Extreme Tuning Utility, make sure to set your CPU vCore mode to manual. Okay? Very, very important. If you don't do this, your CPU will get overvolted. Most programs do not know how to deal with adaptive voltage in terms of stress testing, and your CPU will be overvolted. You'll generate more heat. You typically won't break anything because Intel CPUs are smart. They know when to shut down. They know when to throttle down. But it's not a good idea to overvolt your CPU. That's not the point of overclocking whatsoever, unless you're going for extreme clocks. Okay, so basically finding stability. Now, there's a lot of different memory kits out there, so this is a very, very difficult subject to talk about. So I'm going to try to break it up as best as I can in terms of what are acceptable voltages for DDR3 memory. Now, typically, DDR3 memory 1600 megahertz requires 1.5 volts as a JEDEC standard. Okay, remember we just talked about JEDEC and XMP. Typically, 1866 requires 1.65 volts. Acceptable voltage range for DDR3 is anywhere from 1.3 volts to 1.8 volts. Any lower, it won't run. Any higher, your memory's chips could basically start degrading and get cooked over time or right away. So not recommended you run voltages outside of these parameters. The maximum voltages for different kits, my suggestions are, if you have a kit that is suggested to run at 1.35 volts, do not exceed 1.6 volts when trying to find stability. 1.5 volts, do not exceed 1.7 volts. 1.65 volts, do not exceed 1.8. In my case, my XMP profile suggested 1.65 volts. I was able to obtain that XMP parameter by running 1.71 volts. I was able to overclock my memory from 2400 megahertz to 2666 at 1.78 volts. So that's just a little example of my case with 2400 megahertz memory rated at 1.65 volts. So finding stability, here's what I'm going to suggest, okay? So we've set all of our parameters to auto. Now, if you weren't able to stress test and run for 8 or more hours, this is where this part of the guide comes in. We're going to start increasing the voltage in 0.1 volt increments until stable for a minimum of 8 hours. Once again, 8 hours is the magic number. So example, if we loaded the XMP profile and it set our voltage for 1.35 volts, we're going to increase that voltage to 1.45, 1.55, etc. Keeping in mind the previous acceptable voltages, which I just touched upon on the previous slide. If we find stability by increasing the voltage, the next thing we're going to do is we're actually going to decrease it by 0.05 and check to see if it's stable for 8 hours. Now you can do this backwards. You can start increasing the voltage in 0.05 increments. It's completely up to you on how you approach it. This is just my personal suggestion, the quickest way to find stability. So basically, and the reason we would decrease it is because we want to run the lowest voltage we possibly can for our memory to be stable. Okay? So what this means is if you bought a kit and the XMP profile says, well, this kit runs at 1600 megahertz at 1.35 volts. You might not find stability at 1.35 volts. You might have to increase it to 1.4, 1.45, 1.5, 1.55 in order to be stable at 1600 megahertz. And this is normal, okay? Once again, XMP profiles are merely suggestions. They're not officially supported, okay? And my kit, once again, was rated at 2400 megahertz at 1.65 volts. My kit also required 1.71 volts in order to be completely stable. So the XMP profile in that sense was false. All of the parameters were correct. It was able to run all the default timings and speeds with the XMP loaded, but not with the XMP voltage. So I manually had to increase that to 1.71 volts. If you still haven't found any luck by increasing your voltages manually, the next thing that you could try doing is increasing your timings and frequency manually. For example, if your kit is suggested to run at 1600 megahertz, 99924 at a command rate of 1T with a voltage of 1.5 volts, basically go into the BIOS and input that manually. If you don't know how to do that, at the very last part of this guide, I'm actually going to just quickly show you how to do that manually. Once again, input the stock values and then increase the voltage to the suggested voltages that we talked about already, okay? So we're kind of at this point we're almost eliminating the core variables that the XMP profile manipulates. It also manipulates a lot of other values that are left set to auto. However, these are the core variables. Your main timings, your CPU frequency, the command rate, and the voltage. So input these manually and start increasing the voltage to an acceptable voltage range. If still no luck whatsoever, try to maybe scale back your memory frequencies. For example, if your memory kit is suggested to run at 2133 megahertz, maybe scale it back to 1866. Try to stress test. Once again, we need 8 or more hours to be stable, and see if you can find any stability in that regards. If still no luck whatsoever, contact your memory technical support and load the values that they suggest, okay? Once again, they may only suggest or recommend the JDEC standard, which is kind of crappy. So if you bought a 2400 megahertz kit, they might suggest loading values of 1333. So once again, if you're considering buying a kit, maybe contact the manufacturer technical support team and see what they will or will not officially support before you buy a kit, and try to load those values up before you can consider your memory units defective. So I'm just going to go quickly, and first I'm going to load up the XMP profiles. I'm going to show you what happens when you do that, and if your computer blue screens right away. and then I'm going to show you how to change the voltage, and at the end I will show you how to manually input the timings, frequency, and voltage. So I'm just going to do a quick restart here and go into the BIOS. And show you how to do this. So once again, hopefully if you've made it this far in the guide, you found CPU stability and your maximum ring bus stability. So for me, I'm going to go back into my overclocking here. So I've got my memory set right now for 1333 as per the beginning of this guide. Now I'm going to set that value to auto, okay? The next thing I'm going to do is set the DRAM configuration, the DRAM timing mode is already set for auto, so it should be set for auto if you haven't changed anything as per the earlier parts of this guide. Now the last thing I'm going to do, we have our DRAM voltage set for 1.5 volts. I'm going to change this value to auto. Okay? Once again, XMP changes your speed, timings, and voltage if these parameters are set to auto. The last thing I'm going to do is I'm going to load up the extreme memory profile. Now I've got two to choose from here. I've got, let's see if she'll focus for you, disabled profile 1, profile 2. So profile 1 loads my 2400 megahertz profile, and profile 2 loads up the 2133 profile. So I'm going for 2400 megahertz because I'm a megahertz junkie. So that is the profile I will be choosing to load up here. Okay. So now, if all goes well, we're going to just hit F10 and save this setting, and let's see what happens. So we posted, Windows is starting. Ah, blue screen right away. Now I've already gone through all of these motions to find stability at 2400 megahertz, okay? So I already know what the problem is. It's my voltage. So what I'm going to do is go back into the BIOS here, and I'm going to manually set my voltage for 1.71 volts. Well, 1.7. And it gives me two options, 1.695, which I know is not stable, and my next value I can increase it to is 1.71, which I know is stable. So that is the value that I'm going to choose. Save configuration and reset. And I'm going to boot back up quickly here. Now once again, once you are able to boot into Windows and run your stress test for 8 or more hours, you can consider your memory stable. I prefer to use the Intel Extreme Tuning Utility CPU stress test because I know I validated the memory or the CPU and the CPU ring bus. So right away, boot into Windows. Just load up the CPU Z here. Okay, so we're still at 4.4 gigahertz. Everything's good. Here's our memory, 2400 megahertz. If you don't know, DDR is considered double data rate, so whatever this value is, it's double that. So I'm at 2400 megahertz. Looks like my XMP profiles have loaded. 11, 13, 13, 32 at a command rate of 2T. And we're good to go. So the next thing I want to do is boot up my stress test. So you can choose, I don't think it's going to focus for us here. So you got your two options, CPU stress test or memory stress test. So start stress testing on the memory stress test. I always choose 2 days personally. And I let that go, and hopefully she runs 8 hours or more. So as you can see, it's, the system is not utilizing very much memory. There's 16 gigabytes total, and it's only utilizing 3.5 gigs really. So if you prefer to use a different memory stress test, make sure to set your CPU vCore to manual. Otherwise, this voltage will increase. Usually about 1.7 volts, or sorry, 0.17 volts. So I know this is stable. So again, my temps are looking pretty good on my delidded CPU here. So I'm just going to do a quick restart and just show you guys quickly how to input your timings manually. Now the timings that I show you to input, all the values I show you to input are the core values. They are not all the values. There are so many values you can adjust when it comes to memory. So like I said, if you're having a hard time finding stability, the last thing you can try doing is input everything manually. So basically, the first thing that I'm going to change is my DRAM frequency. I'm going to change it from auto to 2400 megahertz as suggested by the manufacturer. I'm also going to change my timing mode from auto to link in this case. Unlink gives you link will basically be the best one that you should use, okay? The next one I'm going to change is the DRAM, advanced DRAM configuration here. So here I already know that the so the command rate is a value of 2, and I know my kit is, I do believe, 11, 12, 12, 36, and that's basically all you need to change in terms of the settings for the RAM. And basically, I could be wrong here, but I do believe, I'm not sure, if you look on the left you're going to see what the auto values were, and I'm not sure if that was the 2133. Anyways, sorry, actually I should be able, no, that is, so if I look back here, the XMP profile actually tells me 11, 13, 13, 32 at 1.65 volts. So that is the values that you should try to manually input, 11, 13, 13, 32. And if you're not sure on the command rate, that's what this is up here. And typically it's for 1600 megahertz to 2133. You could be running a command rate of 1T. Anything above 2133, even 2133, or even 1666 can be a command rate of 2T. So once again, check your memory specifications and see what the command rate is rated for. It's either 1 or 2. Okay, so that's setting the DRAM timings. So that's all set, and then the last thing, we've already set the voltages. So as per the, you can try to manually go 0.05 volts at a time. Hopefully you can find somewhere in the specifications, like I showed you with my kit, that it actually required 1.7 volts. This can be a headache, so make sure you set your voltage as well. Okay guys, I hope this has been helpful. Part 3 of the Intel Haswell overclocking guide, finding memory stability. Comment, subscribe, like this video, check out my post at Linus Tech Tips, and hope you guys enjoyed. Have a good one.